So aquatic biomes also are based around their abiotic factors, but there's a number of ways in which those factors are different in the way they apply to aquatic biomes than they do the ones on land. Most of them are the same type of biomes, with the exception maybe of like pH or something like that. It's almost strictly a water property. But a lot of them are not limiting factors or in short supply like they are on land, and vice versa. So we'll go ahead and go through a couple to show you what I mean. Obviously, the number one limiting factor on land, what is the number one limiting factor on land? Let me put it that way. Rain or precipitation, water level, water availability, right? So that's what makes the desert a desert, a grassland, and so on. That's not going to be a limiting factor in the ocean, right, or in a lake. Wetlands, yes. If a wetland stays too dry, stays dry for too long, it should flood every year. If it doesn't, couple seasons sometimes it takes, but it'll kill it. Or if it gets too much, then and it stays flooded, it will no longer be a wetland. A lot of the species that are there that need to be immersed or drained will die off, and it'll change into a different ecosystem. So, but otherwise, out in the open ocean or in a coral reef or in a lake or something like that, the water obviously is not going to be a limiting factor. One thing that is a limiting factor in aquatic ecosystems that is, for the most part, not on land is oxygen. Because as you know, we have about how much oxygen in the atmosphere, percentage-wise? About 20%, right? You guys should know that. You should memorize that. About 20% oxygen in the atmosphere. That's more than enough for any respiring organism to survive on land. Now, sometimes it will become a limiting factor as you go higher in elevation, but usually by the time the low oxygen hits you, you've also been limited severely by how cold it is. But for the most part, there's always plenty of oxygen. The organisms don't have to worry about that. However, in the water, it has to be dissolved, and the water does not really hold that much oxygen. So in many aquatic ecosystems, it is a limiting factor. We also saw this, if you remember, when we talked about water pollution and how organic waste will cause the oxygen levels to drop, and only certain things will survive through that. That means that oxygen has become a limiting factor. So that's another thing that's different between land and sea. And temperature is much less of a factor. Okay? Because water has a way of regulating temperature. And it can get almost as warm. I'm not sure what the highest sea surface temperatures are, but I know that they can get into the 90s in some areas. The highest recorded land temperature, I believe, was 127 or somewhere around there in Death Valley. But the real big difference is in how cold things can get. Seawater will not freeze because of the pressure. We've talked about that particular property of water that has to expand to freeze. And so its minimum temperature is going to be around 4 degrees Celsius, which is like 39 or something like that, 38 Fahrenheit. So it's not going to get anywhere near as cold on land. It can get down to negative 170, I believe, was the lowest recorded temperature. So obviously a big difference there. Okay. Water chemistry is something that is going to be an issue. Salinity, pH, dissolved oxygen, amounts of various nutrients, iron, all those other kind of things that are dissolved in the water, that can vary quite a bit. And so that's going to be more of those things are going to have more of an effect in an aquatic ecosystem. Salinity, maybe a little bit sunlight, not really so much substrate temperature. Definitely, well, it does affect pressure. Nah. Depth is another prime abiotic factor in an aquatic ecosystem, is how deep it is. Because like it says there, it's going to affect how much sunlight penetration you get. In the ocean, you hit a point at about 1,500 meters deep where it's complete blackout. So that, of course, is going to have a big effect on what kind of organisms exist there. Also, you have effective temperature, of course, so it's going to be hotter at the top, cooler as you go down. And then pressure, obviously, and it gets, of course, extremely high levels of pressure in the deep ocean. Organisms have to be adapted to that. And as a matter of fact, if you bring those organisms up too fast, you will kill them. They won't explode or anything, but it will cause cellular changes that ends up killing them. Saltwater life zones. Now, instead of biomes, they like to use the term life zones. If we start from the shore going out, you first hit the intertidal zone. That's the area between the high water mark and the low water mark, high tide and low tide. In Florida, the way you can tell, or what you see there, is typically you'll see on the beach, you'll see the seaweed and stuff that washes up in that area. Because we have sandy beaches. So you can't really see much of a difference or much of a intertidal community in areas that have sandy beaches. But in areas where they have a rocky coastline, you have a wide variety of organisms that develop and live in these areas. And when the water recedes back, those rocks and stuff will hold the water there and form intertidal pools. And those happen to be very biodiverse environments that you find there. You can find lots of clams and other kinds of bivalves and sponges and anemones and crabs and other kinds of things like that, organisms like that. So that's an intertidal zone. Unfortunately, like I said, we don't get a lot of those here because they are pretty neat places to look at. Things in that area, they have to be adapted to the fact that they are underwater part of the time and exposed or semi-exposed another part of the time on a day-by-day basis. And also they have to be well adapted, root into the rocks or whatever well, or in the case of, for example, crabs, they're pinchers. You wonder what do you think crabs' pinchers are for? What do they use it for?
Grabbing on the rocks.
Holding on to the rocks. Now, granted, they do use it for their food and stuff, and they use it defensively, etc. But the main adaptation that it's for is holding them in place when the waves come crashing in and things like that, or you have high currents in other areas like that. That's primarily why they have that particular adaptation. They have very strong. Anybody ever been pinched by a crab? Yeah. They pinch pretty hard. So that's an adaptation that those have. Then you have the neritic zone, basically, that goes from the low tide mark all the way out to the edge of the continental shelf. Okay. That is, this is going to be a very biodiverse, this is actually the most biodiverse area of the ocean, diverse, for a couple reasons. Number one, you have areas, this is about the only place in the ocean where you're going to have sunlight penetrate down to the bottom. So you can have producers and like coral and kelp plants and seagrasses and stuff that can be rooted into the bottom and still get enough sunlight to grow. So that's an important factor. They also get a lot of sediment is good. I'll take that. This is where they get it from. They get a lot of nutrients in the sediments from the runoff from rivers, because of course the rivers drain across the land, empty out into the ocean, and that's actually where your continental shelf comes from. It's from the constant erosion and deposition of sediments as the water drains off the land and empties out into the ocean, takes sediments with it, and those are deposited, and they have built up that shelf there over the years. That's also why, since many of these sediments and things are organic, they have fish waste and everything else in them, why the continental shelf is a particularly good area to mine for petroleum and natural gas. Because, because over the millions of years, those organic sediments have descended and compressed and everything else like that and formed deposits there. Yeah, so that explains why that area is so biodiverse. Any questions? Aquatic life zones so far?